All right, we're going over the Unit 1 EOY questions that we reviewed yesterday. Let's go to work. Now, all of these questions that we're doing, there's 6 of them, are similar or the stuff that we've talked about here in Unit 1. This first one is the most fundamental thing that we did, where we need to evaluate the function. What does it mean to evaluate the function? It means to plug it in. So all we have to do here is take this 12 and plug it into that equation for x. But we're going to use function notation. In other words, we're going to say, hey, f of 12. What happens when we insert 12? 2/3 times 12 plus 3. I know I wrote my 12 a little bit hinky there, or funny looking, but I did that because I know I need to multiply fractions, and in order to multiply fractions, it's better if I'm multiplying 2 fractions. 12 is the same thing as 12 over 1, yes? To multiply that, 2 times 12 is 24. 3 times 1 is 3, plus 3. Now, a fraction is really just a division problem. I don't know if you realize that. What's 24 divided by 3? 8 plus 3 is 11. So f of 12 is 11. Is there another way I could write that? Come on, we're having fun now. Is there another way I could write that? Absolutely. What's my input? 12. What's my output? 11. These two items are exactly the same, just 2 different ways of writing the same thing. Any of you, Miss Gabby? Miss Gosser?
Yes.
Does your mama have a pet name for you that she uses when you're in trouble?
My middle name?
Would you say it like your mama does? McKenna Brand. You're in trouble. You know you're in trouble when you hear both names, right? Yes.
You're dead.
Whew. But it's still you. Yes? Same name, it's still you. Here's 2 different ways of writing the exact same thing. You need to be able to recognize that because we get confused when things don't look the way we're used to it, right? I see all the heads nod. All right, next question. Henry places X marbles into an empty bucket. Each marble has the same weight. The weight in ounces of the bucket and marbles are calculated using the expression 3x plus 8. What does the term 8 represent in a function? Now, before I get into answering that question, I just want to review with you. Do you see this 3x plus 8? See that? What does that look like? It sure looks like y equals mx plus b. What is m? Slope. I like this other name for it better than slope. And here's why. This example is why I like the other name. What's the other name? It's another name for slope. Rate of change. Rate of change. Rate of change. What is b? Yeah, it's the y-intercept. But what's another name for it? The initial value. I ain't gonna lie. I like these names. And to be honest with you, I only started using them a couple years ago. But I like those names because when we talk about real applications or word problems like this one, that makes a lot more sense. Rate of change and initial value. So that's what this is. This 3 is the rate of change. And 8 is our initial value. Again, I'm not looking at the question yet. What does that tell you? What does the 3 tell you? It's going to rise 3 and run 1, but it's 3 times whatever that x is. Well, what's x? What's x? The marbles. I wonder how much the marbles weigh. 3 ounces. You know what I'm saying? Like we should be able to decipher that from the equation. Okay? All right, back to the question. What does the term 8 represent? What is my initial value of 8? What does this 8 mean? Yes, sir, Mr. Burns. The weight of the empty bucket. The weight of the empty bucket. Do you see how that is? What's the initial value? What did we start with? Before I had any marbles, I had an empty bucket, right? And I'm going to place those marbles in the empty bucket. So it's 3 ounces for every marble plus whatever the bucket weighed. By a show of hands, and please be honest, how many got that one right? Good. Good. Next one. Which scatter plot represents the data that would be best modeled by a quadratic function? Oh my goodness. What in the world is a quadratic function? What is a quadratic function? By the blank stares on your face. That doesn't look good. I guessed. How many people guessed? Hey, guessing's better than leaving blank. Okay, but here's a case of something we've talked about multiple times. And I need you to transition from when we talk about it, getting that knowledge in your brain. Okay? How are functions named? No. It's not the first thing. You don't name it by the first thing that you see when you walk out of the tent. Yes, McKenna. By their exponent, by their degree, by their power. Yes? What's the one that's called, what power or degree then is a quadratic? Second power. So we're talking about y equals x squared. Yes, sir.
Is the quadratic also the parabola?
Quadratic is also the parabola. We need to know that. So basically, it's asking you, now take it what I just said, a quadratic function. We should know a quadratic function is the 1 to the second degree whose graph is a U-shaped graph called a parabola. Okay, we should know that. Now, which one of those looks U-shaped? This one? This one? This one? Or this one? C. Now, it's only half of it, right? But it should have been C. How many people got that one? Is there anybody in here that got that one without guessing? Thank you for your honesty. Thank you for your honesty. Okay? I appreciate that. All right, number 16. Number 16 is a great question because of what we just finished working on, Kaya. One of our sections was contextualizing. Anybody remember what the word contextualize means? Maybe we need to start having vocabulary quizzes to put it into context or into a real world situation. Okay? You read graphs. We read graphs and we determined what they meant. Yes? So here we have a graph. 2 trains are traveling to Columbus, Ohio. A graph is shown representing the train's remaining distance to Columbus over time. What's the independent variable? Time. What's the dependent variable? Miles from Columbus. Okay? Now, I'm not even getting into the question yet. Let's just look at the graph. What does this point right here mean? That's where what starts? Train A. Right there. Train A starts. How far away is train A when it starts? Hey, I really like what you guys said right there. You said that's where it starts, right? That is also the y-intercept, isn't it? It is also known as the initial value, where it starts. I like that. Okay? So, yes, it's where it starts. And how far is it from Columbus? 1,800 feet or miles or 1,800 miles. It's got a long way to go. Now, once it starts moving, what would you say happens? Constant rate of change. It's a straight line, isn't it? I mean, it's a straight line. It looks like it's going the same speed the whole way. Yes, because it has a constant rate of change. And once it starts moving, does it ever stop? No, doesn't stop. All right, let's look at train B. How far away is train B? 1,200 miles. What's it doing right here? It's still in the station. It hadn't even moved yet. It doesn't even leave till when?
3 p.m.
It doesn't even start moving until 1 p.m. Now, once it starts moving, what happens? Has a constant rate of change, right? Now, look, I hadn't even looked at the question. We're just looking at the graph and saying, making some observations. Let's make one more observation. When this thing's moving and when that thing's moving, same speed. Same speed. You see it? Why are they same speed? They have the exact same rate of change or speed. Yes? Okay. Let's go to what the question says. Compare the distances relative to Columbus from which the trains begin their trip. Tom claims that both trains traveled at the same speed over a certain interval. Is Tom right? They did, like from here to here, they were traveling the same speed, weren't they? Okay. Sarah claims that both the trains traveled at different speeds the entire time. No, we've already said they went the same speed when they were moving. Now, the one sat there forever, so they didn't go different speeds the entire time, did they? No. Sarah said, and here's why Sarah's wrong. Now, stay with me. She says they traveled different speeds. If she had just said they had traveled different speeds, she'd be partially correct, right? Because one of them just sat there for all that time. That's a different speed. But she included the entire time, which obviously they didn't do the entire time. Are you with me? Is that a big deal, that entire time there? Yes. Now, that's our first example of how the EOY is going or is designed to trick you. Because, Mr. Garber, you're right. They did travel at different speeds, didn't they? But not the entire time. There's going to be little things throughout this test, this EOY, that you need to be on the lookout. Like, just anticipate or expect them to try to trick you. So make sure you look for all the little possibilities, okay, ways that they could mess with you. Make sure that the first thing I'm going to teach when we get to review it about this end of year test, first thing I'm going to say is, hey, answer the question. Duh, Coach Herman, we're taking a test. Of course you're going to answer the question. Yeah, but I want you to answer the question specifically. For example, on my way to St. Ives, I met a man with 7 wives. Each wife had 7 kids. Each kid had 7 cats. Each cat had 7 kittens. How many were on their way to St. Ives? If you stick to the question, how many were on their way to St. Ives? 1. But most of us, as you start hearing those numbers, you start trying to calculate right away. Yes? How many people were starting to calculate right in there? You know what? It happens all the time. It's like magic tricks. You're looking one place and all right. This should be an easy question. Which graph represents a function whose domain is the set of non-negative real numbers? What? All right. Some things in here to mess with you. First of all, domain. What is domain? X values. Okay, so we're looking for the x's, which is the set of what? Non-negative real numbers. What is non-negative? Why didn't they just say positive? Trying to trick you. Positive real numbers. Okay? Positive real numbers. Which one has only, the domain being only positive real numbers? What's domain? X's. This one has some negatives. C looks good. This one has negatives. This one has all positives. Why is it not? Because it's not a function. It fails the vertical line test. It is not even a function. So it says which graph represents a function whose domain. Are you with me? This last one?
Yep.
Last one. Again, what are you seeing? Before I even start answering it, what are we seeing right here? More specific on that equation. Y equals mx plus b, but they got it y equals b plus mx. Is that a big deal? No, but again, they're just trying to trick you by making it look a little bit different, making sure you know exactly what we're talking about. So what is this 6? It's my rate of change. What's the 40? My initial value. Okay. All right. Let's look. To start a collection of comic books, Joylin's uncle gives Joylin a box of comic books and several monthly subscriptions to comic books. The number of comic books in her collection, Y, after X months, is modeled by the equation. What does the number 40 represent in this equation? Well, you've already told me it's the initial value. So he gave her a box. That must be how many comic books were in the box she received. See. Cool. Did anybody get all 6 of those right? Good. Good. All right. That's that.
Can we just like throw it away?
Keep it. Of course.